Today on Capecho's Corner, we're going to look at operations with radical expressions. So let's start with a little bit of review that you did in Algebra 1. So we have the square root of 27 over the square root of 3. We can simplify that to the square root of 9, which we know simplifies to 3. Okay, now in number 2, the 3 in the bottom, we can't divide 16 and 3 evenly, and the 3 is not a perfect square. So we're going to have to rationalize the denominator. For the first thing we're going to have to do is we're going to have to split those. The square root of 16 is 4. We have 4 over root 3. So we multiply top and bottom by root 3. And my final answer is 4 root 3 over 3. So in number 3, we have 20 over 6. We can either split that there, or sometimes it's either easier if I can simplify that fraction first, then my numbers are a little bit lower to deal with. So I have the square root of 10 over the square root of 3. Okay, I'm going to rationalize my denominator. Remember, that means I'm going to make sure I don't have a radical on the bottom. And I end up with the square root of 30 over 3 as my final answer. Okay, just some general rules on simplifying radical expressions. Okay, so a couple things. We're going to work with an index, which is something other than 2, which we'll talk about. The radical contains no factors other than 1. Basically means we don't have anything underneath the radical sign that we can simplify further. We can't have a fraction under there, and we know that we can't, just like in our in our review session there, our warm up, that we can have radicals up here in a denominator. All right, so let's start by simplifying some basic ones. And number 1, what I like to do is, I know that 32 is not a perfect square, so I do like to split this into a radical sign that has perfect squares and a radical sign that doesn't. So in 32, that's 16 times 2. So 16 is my perfect square. It goes under the first one. And then the 2 is not a perfect square. It goes under my second one. Now, x to the 9th. I know that x to the 8th, because it's even, is going to be a perfect square. So I'm going to put x to the 8th right there. I still need one more x because it's x to the 9th. And then x is going to go there. So that leaves me with 4. X to the 4th times the square root of 2x. All right, we're going to do the same thing with the second one. So I have 2 radical signs here. The highest perfect square that goes into 12 is 4, so that gives me 4 and 3. A to the 6 is even, so that's a perfect square. That's going to go there. B to the 5th, I'm going to put B to the 4th under here, and then I have B over there. And then I have C to the 1st is going to go under that second radical as well. So this simplifies to 2, A to the 3rd, B to the 2nd, all under 3, a radical sign with the square root of 3bc. Okay, so now we're moving on to the third root. So every time I write that, I still have to write that 3 by the radical sign. So 27 is a perfect cube. That's going to go there. Y to the 12th. 12 divided by 3 does go evenly, so I'm going to put that underneath my first one. That's my perfect cube radical sign. My z to the 7th. I can take z to the 6th because 6 divided by 3 goes evenly, and my extra z is going to go there. So my final answer here is going to be 3 y to the 4th, z to the 2nd, all to the third root of z. Okay, another one like this. Again, this time we're doing with the fourth root. So again, I have my fourth root here. I have another fourth root there. 16 is a perfect, we can take 16, the fourth root of 16 is 2, so that's fine where it is. A to the 24th, because 24 divided by 4 goes evenly. This is going to give me B to the 12th, B over here, and then C to the 2nd over here. So that leaves me with 2, A to the 6th, B to the 3rd, times the fourth root of BC squared. Okay, a little bit more on rationalizing the denominator, which we talked about in the beginning, is to eliminate radicals from a denominator or fractions. We use a process called rationalizing the denominator. That means we're going to multiply the numerator and the denominator by something so that the radicand then becomes an exact root. So for instance, if I have to the square root, which we started with in our little review in the beginning, this root 3, I need to multiply top and bottom by root 3 so I could get a value underneath the radical sign that does not have the square root. Now, when we're working with something other than the square root, in this case, the index in this example is 3, and I have 2 to the 1st. Now I need to get 3 of them, right? So I need to get 3 2s. I already have 1. So what's gonna happen is when I multiply, I need top and bottom. I need 2 more. So I'm gonna multiply top and bottom by that third root of 2 squared. And again, we'll practice that. That becomes a simplification that we can deal with because I no longer have a radical sign on the bottom. Okay, next one we have the square root of x to the 6 over the square root of y to the 7th. Now, remember my index that's not there is 2, so it means I need an even power. So I have y to the 7th on the bottom. I need one more square root of y to the 7th. I need one more square root to give me an even power. Okay, so my this right here becomes a square root of y to the 8th, which is what I want. As long as it's even, I'm all set. So my numerator becomes x to the 6th over y. I'm sorry, x to the 6th, square root of x to the 6y over the square root of y to the 8th. So that simplifies to x to the 3rd square root of y all over y to the 4th. All right, let's look at the next one, number 6, same sort of idea. I have the square root of a to the 9th over the square root of b to the 5th. I need to multiply top and bottom by the square root of b. So I end up with the square root of a to the 9th b over the square root of b to the 6th. So again, I have some odd powers in there, so I have to split it. So this is a to the 8th is my perfect square, and I'm left with ab all over b to the 3rd. So my final answer will be a to the 4th times the square root of ab all over b to the 3rd. Okay, moving on now, we have a fifth root. Okay, so I have the fifth root of 3 over the fifth root of 4y. Now, the interesting thing about this one is this fifth root of 4. Remember, 4 breaks down is the same thing as 2 to the 2nd. So I need 5 of those, and I only have 2 so far. So I'm going to multiply top and bottom, my fifth root. I need 2 to the 3rd, right? You can write that as 8 if you want, but I know that's what I need. And then I need y to the 4th. I need 4 more of those because that's just y to the 1st. Multiply the same thing on the top. That gives me 8y to the 4th. So now when I start simplifying, I have the fifth root of 3 times 8 gives me 24y to the 4th on the top. And the bottom now I have 5. And I'm going to break this down. This gives me 2 to the 5th, y to the 5th. Okay, so my final answer will be the fifth root of 24y to the 4th all over 2y. Okay, last one like this, same idea. This time we're going to do the fourth root. So the fourth root of 6 over the fourth root of 5x. Now, I only have one 5, right? So I need 3 more 5s. So I'm going to take the fourth root of 5 to the 3rd because I need 3 more. And the same thing with the x. I need 3 more of the x's as well. So on the top, I'm going to do the same thing, 5 to the 3rd, x to the 3rd. That's my fourth root. So on the top, I have 5 to the 3rd is 125. So when I multiply that by 6, I get 750. And then I have x to the 3rd on the top. And the bottom will simplify to 5x. Okay, moving on. There's a lot of division there. We're going to do some other operations with radicals. So let's see, again, we're simplifying. So let's look at number 9. This time we're multiplying. So we have 2 numbers on the outside. We're just going to multiply them together. They're going to stay on the outside. Now, instead of simplifying each fraction underneath individually, instead of doing this one and this one, I'm just going to multiply it underneath and then I'll simplify it one time at the end. So 8 times 2 gives me 16. C to the 3rd times C gives me C to the 4th. And then I have D to the 8th. Okay, so again, that 24 goes out front. Now this under here, this is all a perfect square. So this gives me square root of 16 is 4 times c to the 2nd, d to the 4th. So my final answer there is 96, c to the 2nd, d to the 4th. Okay, and number 10, I'm dealing with the fourth root. So again, I have 2 times 3 up front. That goes to 6. Fourth root of 8 times 2 is 16. I get x to the 8th, y to the 4th. Now, again, each of these is we have a fourth root that is going to work very well for us. The fourth root of 16 is 2, and then I get x to the second and y. So my final answer there is 12x, 12x to the second y. Final answer. Okay, that was multiplication. Now we're going to do some subtraction. Again, I need to simplify. So this gives me the square root of 49. That's my perfect square times the square root of 2. Minus 2, square root of 32. Highest perfect square is 16 and 2. So this gives me 7 root 2 minus 2 times the square root of 16 is 4 minus 2. So I get 7 root 2 minus 8 root 2. So my final answer there is negative root 2. All right, number 12. I have a binomial times a binomial. So I'm going to use that FOIL process. You can distribute if you like that method better. I like using FOIL. So my first, 4 root 3 times 3 root 2 is going to give me 12 root 6. Okay, then I'm going to deal with my outside, which gives me negative 4. I'm sorry, 4 is out front and 6. So 4 times 6 is going to give me negative 24 root 3. And then my inside right there is going to give me plus 15. Root 2 times root 2 gives me 2. And then when I look at my last terms, I have 5 root 2 times negative 6. That gives me negative 30 root 2. Okay. Now this is going to be 30, but there's nothing else. I have a root 6 here and a root 3 and a root 2. So I really can't simplify that any further. So my final answer is 12 root 6. You could actually you could either just kind of erase that and fix it if you want, minus 24 root 3, minus 30 root 2. I'm going to put that 30 at the end. It really doesn't matter. But so that's my final answer right there. It looks like a lot because I can't combine anything. I don't have any like terms. Okay, for our last one today, we have radicals on the bottom, but it's not the whole thing. Just that first term is a radical. So again, I have to multiply by the conjugate. Remember, the conjugate is when I have a binomial, and I'm just going to change that sign. Oh, I'm just going to change that sign. So I have 5 plus 1, and I'm going to have the square root of 5 plus 1 on the top as well. So my numerator becomes 2 times the square root of 5 plus 1 all over square root of 5 times square root of 5. I'm going to use FOIL now, right? Because I have a binomial times a binomial. Square root of 5 times the square root of 5 gives me 5. My outside and my inside terms are going to zero out, which is the point of that. And I have negative 1 times 1 gives me 1 minus 1. So I have 2 times the square root of 5 plus 1 all over 4. Now here I can simplify, right? That they're both on the outside. So 2 goes into 2 once, into 4 twice. So my final answer there is root 5 plus 1, and the whole thing is over 2. Last one for today. So I'm going to multiply by the conjugate again. So I have times root 2 plus 3 on the bottom, same thing on the top. This time I'm going to have to use FOIL on the top, right? So I have 4. My outside, my first is 4 root 2. My outside is plus 12. My inside is 2. And my last is plus 3 root 2. My denominator, root 2 times root 2 gives me 2. My outside and my inside terms are going to zero out, which is the point of that. And then negative 3 times 3 gives me negative 9. So when I clean all that up at the top, I have 7 root 2 plus 14 all over negative 7. Now, if you notice here, I do have everything, my numbers, not underneath my radical sign, but my other numbers are all divisible by 7. So I'm going to kind of just give you a better visual of that. So that gives me root 2 plus 2 on the top, all divided by negative 7. So that can simplify. So I'm left with root 2 plus 2 over negative 1. Now, we don't usually see that. We can distribute that, and I end up with negative root 2 minus 2. And I'm all set. It's my final answer. We did a lot of operations with radical expressions today. You did a great job. Thanks for stopping by. Have a good one.